Welcome to the memory tiering and vSAN deduplication demonstration in VMware Cloud Foundation. In this scenario, we've received a request to deploy a new AI-driven CRM application that requires a cluster with GPUs. To evaluate our options, we'll head into the operations console and run a workload what-if scenario. We'll kick things off with a planning session where we add virtual machines to our AI CRM project cluster. We'll select a data center and a GPU-enabled cluster that fits our needs. Based on the vendor-provided specs, we're looking at roughly 90 VMs with a June start date. When we run that scenario against the GPU-enabled cluster, it's clear we won't be able to fit this environment. As you can see, we're already running out of memory. And when we click on disk space, we can see that we are facing similar capacity challenges, so adding this workload is only going to make things worse. So, we now need to see how we can use VMware Cloud Foundation to improve that situation. Looking at our inventory and operations, we can see we have 900 terabytes. We've used 2/3 of that, and that's why we're running out of space. Let's head over to vCenter and enable global deduplication. In the vSAN services, you can quickly see that compression is already turned on as a cluster-wide default, but deduplication is disabled. Enabling it is straightforward. Just click Edit and flip our sliders. When done, deduplication will then begin working behind the scenes at a 4K block size across the entire vSAN cluster. When we return to operations and review the inventory, after everything completes, we've freed up over 500 terabytes and now have sufficient disk space. Now, let's also take a look at memory, since that was the more critical issue. When we optimize the cluster for memory tiering and check resource efficiency, we can see that about 50% of our active memory is consumed while the rest is inactive. VCF operations is automatically surfacing two ways we could scale up. Either add extra DRAM at an astronomical cost of $377,000 or add NVMe tiering for just $56,000. Since purchasing new hardware is not an option, let's go ahead and enable NVMe tiering. Back in vCenter, we navigate to memory tiering in the configuration and toggle the preferred state to true. From there, we select the individual NVMe devices we want to use. We'll just browse through the interface, pick an available device, and repeat that process across all hosts in the cluster. We'll also enable software-based mirroring. Since we don't have extra controllers in this environment, it's the right fit and requires minimal expertise to configure. Simply select the mirror device, then go back and enable encryption for the memory tier as well, since we want everything running securely. We'll also set the tier size to 100% of available memory, hit save, apply the changes, and we're done. The system will now check to confirm there's no disruptive impact on hosts or clusters, and as we can see, the only change is placing hosts into maintenance mode. The configuration is being remediated and memory tiering is being set up in the background. When we return to the summary view, memory tiering is enabled. We have nearly 4 terabytes of total memory in use, with 2.5 terabytes in DRAM and 1.26 terabytes sitting on the NVMe tier. That's a dramatic shift in how we're using resources. Back in operations, we can review the throughput, bandwidth, and latency, all the global statistics for our NVMe memory tiering. And when we check our current state, that recommendation has been cleared. We're good to go. So, let's run that planning scenario one more time. Now, when I rerun the what-if scenario, the green numbers tell the story. Our AI CRM application is now ready to deploy. We have sufficient capacity for both memory and disk space. By using memory tiering, we saved approximately $320,000 on this one cluster alone by avoiding the need to add extra DRAM. On the storage side, deduplication and compression saved another $215,000 by eliminating the need for additional storage, which brings the total savings on a single cluster to $536,000. That's an enormous amount of savings.